Sorry, we ran into some technical difficulties. I am lying to you. I am not Fran Parathyris. My name is Andrew Kisson. I'm the head of marketing for Zon Dental. We're here with Dan Marrano of Marrano Dental Arts. Dan, please, without further ado, since we're already running a little late, please give our attendees an overview to you, your laboratory. We appreciate all the support and knowledge that you drop in Zon Academy, and are excited to see and hear from you regarding the demystifying full arch screws.
Yes, thank you. Thank you for having me again. I look forward to speaking about this. It's something I've become passionate about so much where my brother tells me I have an obsession with these screws. And it's because they're in our lives every day now. We get calls weekly, what about this screw? What about this screw? What do you think about this screw? And then things drop in the lab. And since I've been using it for years, kind of since the start of and maybe even before many of these screws even came out on the market, we had to overcome a lot of the challenges. So we're at the point now where we have a lot of things set up, and I hope I can share some things with you to help you bring back to your lab. So we'll just dive right into it here. Full arch screws. So what are full arch screws? It's pretty simple. A screw that just securely secures the prosthetic directly to the MUA. Why we use them, it's a fully digital pathway for All-on-X. Different types of full arch screws. We're going to feature the DES 19069 today. It's a screw that we do use here. It's one of them we use here. And manufacturing All-on-X restoration, just generally using full arch screws. Material selection, we will review different zirconias and manufacturing using hyperDENT milled on the Roland 53 DC. When I first was presented with this about 4 years ago from my good friend Dr. Mike, he said, "Do you want to be a part of this?" And my first thought was, is he crazy? So I ran and looked for a study. And there is actually one study, 2019. And this was a study comparing using the direct-to-multi versus Tybase. And this was just using like the bar library, just very thin. I believe it was 0.4 millimeters. It's the only study that I think I know of. And it said it was a viable solution. So does it work? It's been 4+ years and they do work. And they work really well. And even before that, Nobel has kind of used this and promoted it against using a tie base for space, and so that you're not weakening your structure. There are many critics of full arch screws out there. It's unknown. It's unproven. No need to change, frankly. Fretting, which we have not seen any indication of yet. Records accuracy. This is something big. I am big on accurate records. I don't believe you can put an All-on-X in if you don't have an accurate record. We'll talk about some of that later. And manufacturing challenges. 4 years ago, strategies didn't exist for this. Most of the tools weren't even long enough in the mill to mill some of these. So we had to overcome them, and there are some nice turnkey solutions for you available today. The screw today, there are different screws. There are tapered screw versus flat screws. Material thickness under the screw. Angulated screws, should you have an angled screw, or should you re-angulate at the multi-unit abutment? Accuracy of milling, and in that was the tapered versus flat. Some people say you can't mill a flat screw. Some people say you can't mill the tapered screw accurately. What I'd say is they are both, you're able to mill them both accurate with some of the strategies that are available today. Self-centering, that's a debate that goes on. Screws that center the restoration over the hole rather than the screw kind of centering in the screw hole. Good for scan bodies, bad for prosthetics, some people say. So, and here's an example of like a self-centering screw and the forces that are put on laterally versus horizontally. So why we use full arch screws? Eliminating cementing tie bases. If you have accurate records, the debonding is generally not a problem if you follow the protocols for cementing. But you do eliminate the subgingival cement gap. Returns for shade. I had to put it in there because nothing's worse than getting that thing out the door and then it comes back and whatever reason they have to change the shade. Then you got to pull all those out and then put them back in. So eliminating the tie base, you have a greater thickness around your multi-unit. So you're no longer restricted to say, 6 millimeter height and you have to get the width around it. Eliminating the thickness at the base. What that is between your restoration and the multi-unit margin. So they'll be elevated maybe, 0.5 millimeter or something like that with some of these tie bases. You can go right down there. So you can eliminate some of the gaps sometimes where, say, the multi-unit's right at the gingival level. And most importantly, it's a pathway to fully digital all-in-X. This is the most important part of it. What's cool about these is like when you look at the cases and stuff, there's nothing in there. We don't have anything. It's fully digital. It's fully trusting the process and the protocols that we've been trained on and delivering these without any check along the way, like a model. I'm not sure. This is a question I've been asking for a while. What is the biggest obstacle to a fully digital all-in-X? And not everybody gets this. It's the tie base and of course the model. You need that model or a model to cement a tie base to. And the reason is, and here's a couple tie bases I took the cross section of and cemented. And if you look closer, there is a cement gap. These move within there. It's designed this way. And it can pick up some inaccuracies. It can be useful, but you will struggle to cement these by hand consistently and put them out accurately. So what about a printed model? Well, I did some testing on these printed models, and these are 3 different models from 3 different printers, and I compared them to an accurate scan, and you can see they're just a little bit off. We don't want to see any of the orange or red, and certainly not pink. I mean, the desk has little wings on it, but I would not feel comfortable cementing finals to these models. So I didn't come up with this. I've seen this for years on Facebook, I believe. You mill a PMMA bar and then you put analogs on it. And that will give you an accurate um, analog model. And here is a case that I did with it. This is a really big case. At the time, I don't think I definitely didn't have T cutters. This was every bit of a 30 millimeter puck. We put the big, tall desk tie bases in here, and I had to have something to cement it to. So that was what we used with those. The problem with milling that bar is the density and the hardness that causes burr deflection. So anybody that's milled PMMA can understand the struggles that you sometimes get with that. The screw doesn't fit. It doesn't fit on that multi-unit, so you can't use that for a model in those cases. And the ugly truths and type bases, these were actually someone's prizes that I pulled off online that they posted as kind of, look at our work. And you can see the cement gap. And frankly, the cement is not even cleaned off. So that's no good. We don't want that. So if we could avoid that, that would be great. Now, what caused that? Sometimes cementing these, 6, 8 in the lab. Sometimes it gets warm in the lab. It starts to cement set up on you. I'm not sure I'm sure some of us have had this happen, but you generally have to pull these out to proceed and start over. So can you use a bar for a fully digital pathway? Yes, you can. You can cement that bar in your restoration without a model. I don't do a lot of bars. I don't promote bars. The bars and the pathways to get your prototype to final have been challenging. I know there's some softwares out there, and the word is exocad 3.3 should have a nice workflow to get that. But recently I've had to figure out my own because I've outsourced these and tried to get it to work and just nothing ever fits. They deliver you the bar, they deliver you the sleeve, maybe mill your zirconia, or maybe you have them both mill, and it just, there's gaps. I'm just never happy with them. So I did just recently have to develop my own protocol within 3Shape to do this. And I'm a stickler to like try to get it exactly the way my prototype is. So here's our demo case. Um, and I created the bar and the bar module and adapted it to our demo and demo our prototype that we would have delivered. The tissue is exact, the emergence is exactly the same. And then I split it with the sleeve. And this is maybe something we can go over. We have a webinar next month. Maybe this is something we could put in there, something that I felt was pretty easy. Um, and I'll show you this. For a little while. I was using my brother's video, and I thought, well, I should make my own. So this is a case this was the sleeve was hot off the oven today, dropped right in. Not a single adjustment. This is perfect fit. It's actually better than most of the ones I've had from outsourcing, even when they do kind of work. And rescanning the bar. This worked really well. I'm really happy with this workflow, and maybe I'll share it with you guys in a month. But that is not something I even like to do. I don't like to go through all the bars. I believe in my materials. I believe in the screws. And you can use the desk screw or your favorite screw in those bars as well. And this is where we come up and we have all our screws. These screws are still coming at us today. I think there's at least two that came out this year, and we're getting questions constantly about them. I'd like to review the categories of the screws. We got the flat screws like the desk screws, and we have the tapered screws like a Rosen or a Vortex, straight screws versus angulated screws. Now, when it comes to flat screws and tapered screws, I don't necessarily have a preference on that. I'm not going to lean one side or the other. There's a lot of that discussion online. I'll leave it to them. I think they all kind of work. I do prefer an angulated screw, and I like them that they go 25 degrees now. Repurposed screws versus designed specific full arch screws. I am transitioned all to design specific. We don't need to reuse a repurposed screw that was meant for another reason. I put this in here just to note there are different multi-unit sizes, 1.4, 1.6, 1.8. We will be talking about the 1.4. It's the Nobel compatible. 19069 is the desk part number. And we'll start with the tapered screws. Many of you may have used some of these, and maybe not. It's okay. We put this together to show you them. We'll start with Rosen. This was one of the first screws I had. I had the Rosen original. It was not meant for angulated screw channel. They have since come out with angled screws with the T5 driver. Now, when you see these angled, it says 30 degree. That's if you can get that to mill. So keep that in mind. It may be capable of 30 degrees, but it's all restricted on your manufacturing capabilities. And the Rosen SH was meant for more FP1s, and it uses a different driver. They torque to 20 nanocentimeters. And here they are. And this is how I go through every time I get a screw. I don't go to my final restoration or even a prototype. I start building these cross sections and small cases so I can see that I can manufacture this properly. The middle one is their Rosen Wave, and then the SH is on the end there. We have Vortex. Vortex, I use a lot of Vortex in the lab. I'm very comfortable with Vortex. It was designed for all NX. It's a hybrid tapered. It's got tapered walls, and it also sits on kind of a round seat. You can do 25 degrees angled screw channel. I would say, again, with your T cutter. It has a small access hole, which I do like. T5 driver, 15 nanocentimeters. And I like the varied material thickness that you can choose underneath the head of the screw. That way, say if you have an FP1, you can go a little bit less, or you can go a little bit thicker if you have a taller FP3. And here's the vortex screw. Again, this is a screw we use a lot in the lab. I like the screw. Um, and we've come from a long way with that screw as well. The seg screw, I don't have a ton of use in the lab with, but again, I use all the screws that come in the lab. It looks like a very robust screw, um, and it has plenty of material under the head. It is a tapered screw. And the Powerball screw, many of you may be familiar with the Powerball screw. Um, it needs the Powerball driver, different torque values because there is two versions of the screws now. Very thick, very durable, robust screw. I don't use a ton of Powerball in the lab. I have used Powerball 1. I have not used Powerball 2. Um, but the purpose of Powerball 2 is to more have that sealed um, sealed cavity, as it was explained in some of the videos of it. But very good, very long, 2 millimeters of zirconia underneath there, so you don't have any concern about zirconia cracking with that. The Badger screw is one of our newer screws. This thing has gotten some ton of calls on this all over the internet. I just bought it just for this for now. It has 12 degrees ASC angled screw channel right now. Ideally we don't like to crank screws back 20 degrees, but we do. It just, something that happens. So you'd have to be cautious with that. It has a small screw head diameter, and it looks like that, the Badger screw. Flat screws. A lot of flat screws out there. They seem to be more common, maybe just because there's more desk screws. Um, but there's the Dental PRH 30. This was a repurposed screw, similar to the desk long screw, flat surface, a lot of material underneath the head of the screw, narrow head. Then they came out with the smart angled screw, 25 degrees angled screw channel, that's angle base driver. This also is a flat seat underneath the head. You can see it there. I like that it's black. I do like these colored screws. Um, they're fun to have the different colors in the lab, and you can identify them easy, and I'll show you an example of that. The All-in-T direct screw. There is no angled screw channel, so I have not used this very much. That's it there. And this was the first screw I ever did one of these direct to multis. And you think, are you crazy? And yes, because it was designed for a tie base or a bar. And I thought it was crazy. What I will say, and I would never use it again, every one of these restorations is still in the mouth. We've never gotten one back. And it was a photogrammetry company, I believe, that developed the one on the right with the 0.6 material thickness. That study that came out was with the one on the left with the typical 0.4. This is way too thin to make a zirconia arch on. The desk long screw, this is still popular today. It's actually the uni screw. There is an angled version of it, 19406. I have not used a ton of these in the lab for finals just because we've had other options. Again, there were two libraries that I had at some point, one with 1.0 and one with 1.2. Again, it's a repurposed screw, and because we now have the desk full arch screw, I used a full arch screw. I don't really see the need to use a repurposed screw. This was specifically designed for All-in-X. It has 25 degrees angled correction using the angle base driver. And that's what's important. I've been using desks for years, and Most of my doctors have the angle-based driver at some point. So some of them that are not necessarily familiar with this, it's an easy stepping into it because they already have the driver. There are a number of variations that don't have angled screw channel. They would have like the 050 driver and such. I don't use them. We use the angled one exclusively. It does have a kind of a small axis hole, and there is the 19269, which is the diamond like coating for better grip. I like it because it's black. Um, and this is the desk screw, and it works very well. And we'll go through more depths about manufacturing with it. Has a millimeter of thickness, and that seems more than enough for our restorations today. And why I like the black screw, and I've actually, my finals always come with the black one or some kind of anodized screw, because one day I was sent this, and the doctor's assistant sent me this picture and said, which screw is for this? I don't even know where they got some of these screws. Some of these screws don't even match. I think some of them were from the verification jig. Um, and I picked out which screws were, and I believe it's number 5 and 6 or something like that. And then 5 minutes later, I got this picture because they mixed up the screws and they couldn't figure out which ones they were again. So I don't use the silver screw. I like the anodized screw. I can just tell them use the black screw. So if that's something that happens to you, that's an easy fix today. Here are the comparisons of the three desk screws as we know them. You know, the typical tie base or bar screw, the long screw, and then the full arch screw that we use today for our All-in-X. Some people really like these number values, especially this screw head diameter. There are, you know, small head screws, the Badger screw 2.0. They brag about that. The desk 19069 floats somewhere in the middle. I'm pretty happy with that. And then all the way up to the seg screw. So the point of the screw head diameter is that you're not taking as much material away. You have more zirconia for strength. And I do think that's important. The screw to driver connection. This is something that was started being reported back to me, so I thought I'd just mention it to you guys. It's not a deal breaker for some people. It is. It's the ability to carry the screw on the driver. When we came from the original screws that didn't have any angle correction, doctors bragged that they could like swing their hand around with the screw and it wouldn't fall off, and they could take it from the table from their assistant and move it over. The angled screw channel full arch screws, it varies. Some of them do just fall right off. And I had made this video just to show you. I don't have the screws listed as which one it is. Some of them do stay right on there, and some just fall right off the driver. If that's important to you, that's something to look into. I believe ones that are anodized do stick on better on the end of the driver. Some have been developed, the drivers have been developed a little bit better to stay on there. And some doctors just don't care. Screw torque on provisionals. These screws will loosen on provisionals. And it's caused by the PMMA or the printed resin rebounding. It flexes, deforms, and the screw loosens. Some doctors will say they'll come back a couple months later and the screw won't even be finger tight. Basically, seems like it's falling out. It's important to have obviously accurate records, but assuming they're accurate, this still does happen. And many of us maybe have had it. Do we think it is a big problem? Anyone in the chat, if you want to mention who thinks it is a big problem? I guess it really depends. Some people do, some people don't. Some people bring their patients back a week after surgery, left the screw holes open, and they just go in there and retorque them. I do believe it's one of the many obstacles till we see a definitive All-in-X resin. There are some out there, but I think this is an obstacle to that. So I did do a test, show everybody. I went and took 5 different screws and we manufactured 4 different types of material. We did the Flexer Ultra on our Einstein, the Inox Tough 2 on the carbon, the Rodin Titan on the Asiga Max, and just straight milled PMMA. And we torque tested these. We had a protractor, wasn't super, I guess, scientific, but it got us the numbers that we needed. Now, what does this really give us? Like we see them at the bottom, the Rosen screw. And you'll see as we go through these, it is at the bottom. What I end up seeing when I was all said and done is that it bottomed out on the head of the multi. It actually pushed all the way through the restoration. Now we're not chewing on these, so they could be better or they could be worse. We don't know. Here is the coated versus the diamond-like coating, the 19269. You do get a little bit better grip on them. And this is Titan. And here's all the conversation about preload and flat surface versus the sidewall, a little bit closer up, and how they're saying they get more preload value. This does seem to play a role, but I don't know if this preload is necessarily relevant in zirconia. I don't have doctors calling once we come to zirconia, and many times if they have screw loosening or temporary breaking, the answer is to get to zirconia. And once we are in zirconia, you never hear of it again. I think all these screws, once they're gripped on the more durable surface, you don't have any screw loosening. So the results from that were milled PMMA does generally show less degrees of rotation, less screw loosening. Higher ceramic content resin has less screw loosening. Flat screws have less screw loosening. But I do not have any concrete conclusion from this yet. Not tested this in the mouth extensively, but provisionals, valves, and screws loosen in them. We've had all these screws, flat screws, tapered screws, flat tapered screws. We've had them all. At some point, a doctor tell me, in a provisional, they do loosen. But again, in zirconia, those problems do seem to go away. Passivity. I want to bring up passivity, and again, I'm a big fan of accurate records. I'm a big fan of photogrammetry, and so how do we determine passivity? Radiographs, they're not great. The zirconia is all white. The implant's all white. The abutment's all white. You have to take it at just the right angle, and there's a study that shows I think it's 2 times the acceptable gap by the time you actually see it on the X-ray or the pan. The Sheffield screw test, the one screw test. If you're not familiar with this, you put a screw in all the holes, then you back them all except for one. It's supposed to still stay on there. A lot of times we're putting some tissue pressure on these. I've been told this is not a great solution. The only way to actually tell is to listen and feel. And I've been told these screws should feel like there's butter going in. It's just smooth, no resistance. And when you're working in the lab, if you have one, you can feel that. You can definitely, I had a bar that somebody milled for me, and I ended up throwing in the garbage because the screws, you could just feel it's like grit going in there. And ended up having to send that somewhere else to be milled. So feel that, you should know. And definitely, even when you're milling, and we'll show some of these, you can feel it going into your zirconia. It should be a smooth fit. Zirconia selection. We have all kinds of different zirconia now, 3Y, 4Y, 5Y, all these hybrids coming out. Something to mention right off the bat, we don't use 5Y zirconia for all NX restorations. The other 3 are totally acceptable. We, in our lab, pretty much use the 4Ys today. There's some reasons for that, but it's consistent and strong. And I guess the better versions of the 4Y, I'm going to say, there are some information out there that 4Ys are not made for anything more than a 3-inch bridge. I think that narrative is kind of pushed by the manufacturers that don't have the 1100 megapascal type 4Y zirconias. So for Zahn, we have Dental Direct. And I went, again, we don't use any 3Y in the lab anymore unless we're doing some kind of opaque coping. Um, but here are like the pre-shadeds from Dental Direct, assuming it's pre-shaded. We use all pre-shaded multilayer zirconia in the lab. Um, Cube 1 would be my selection from this group. But if you wanted some more aesthetics, these hybrid zirconias are very highly aesthetic today. And you have that 800 megapascal at the incisal, like in the Nicera Pearl and the Cube YHL. And they're both available in a 25 millimeter disc. So that's very nice as well. A Mongerbach, another solid option from Zahn. I put this Zalad ZI on there. That is their white. Um, I think it's been a number of years. They walked over and went to the DHT Plus. I used to use DHT Plus as well. Then they went to the multi-layer Gen X, and now they have Bion. And Bion is a great material. Has a 30 millimeter disc, which is very nice for when you need to reach for some of these larger all-in X's. Um, and it's highly aesthetic. And they just made a nicer nicer price point a few months ago. Here is why I don't use as many hybrid zirconias. The 3Y, 5Y, if you have a case like this, and the doctor who does these with us calls them chimneys, you had the long subgingival multi-unit abutment. Aside from should that be or shouldn't it be? It is what it is. So you have to get enough strength from that 3Y bottom half of that disc in order to support the strength in that restoration. And you just have to frankly select your size of discs appropriately. Some of the early hybrids were like 650 at the incisal. I would never put this in there. You would never be able to get enough strength at the bottom to put that in while getting the aesthetics at the top of the 5Y portion. Um, but the Dental Direct is 800, so you have a little more leeway with that if you choose to use those hybrids. And again, they are highly aesthetic. Fundamentals of zirconia. I was taught these by my brother, who's been working with this forever. Take care of your zirconia in the green state and the post-sinter state. Follow the zirconia manufacturing protocols. I say this today because it is kind of the wild west of zirconia out there. We're seeing a lot of different manufacturers come out and a lot of different people getting into this because of digital, frankly, and they're able to do it. So make sure you take care of your zirconia. Something he said, everything has changed, nothing has changed. Just because we have a new screw, just because we have a photogrammetry, just because we have a new CAD system, doesn't mean we can forget about the fundamentals historically we've built these cases upon. You need to make sure you take care of your zirconia, passive records, and everything from there forward. So remember that. Almost everything we work in the lab today, you could say everything changed, nothing has changed. So remember that when it comes to zirconia. And a lot of people who are not fans of zirconia, because zirconia warps, it does go through a change. It has a shrinkage. And here are 4 zirconias. I did this a couple years ago, and the 2 at the bottom are zirconias that were developed to mill without a sintering support. The one at the top right is the same as the one at the top left, just without the support to show you what happens without it. And here are those created with a model, rescanned, and compared. Uh, I just don't believe you can take the stabilizers off now. Now, some zirconias are coming out still today, and maybe people have excellent success with them. I still put the stabilizer on. I'm going to continue to put the stabilizer on, especially when it comes to these full arch screws. If you have a tie base and a model, maybe you could pick up some of the inaccuracy with the cement gap. If you have a bar, maybe. But I still think we need to treat our zirconia the way it always has been and take care of it. Here are my supports in hyperDENT. That's my bar. Looks like a 10 millimeter thickness. It does reduce a little bit beyond that. I use only two supports on the outside to hold it in. Hypern is nice along the back side of the bar. It does leave a little connection point, so you don't need sprues all over the face of these things. It helps it mill cleaner. And along the lingual, I have 3 millimeter connectors. So I always put probably five. It's a smaller one, maybe four. If it's even bigger, I go up to seven. I had a bar, a full arch, a pterygoids warp once, and it was only because I was so excited I got in there, I forgot to put enough support structures in there. Um, that'll never happen again. This is the protocol we follow here, and it works very well. Years ago, this had come out and it was monolithic shortcomings, and it drove me crazy. I called my brother all worked up, and I was like, it's not the monolithic, it's not the material. And in this video I had watched at the time, it even said it wasn't passive ed insert. So it's not a shortcoming of the zirconia, it was a shortcoming of the records. Um, so remember that. And direct to multi will not give you much forgiveness, right? So keep that in mind. You will screw these down, and if you don't have passive records, you will get a pop corner like that. This just yesterday, still, my lab is amazing. He verified and convinced this is a zirconia issue. Other pictures in there, it looked like there was plenty of thickness. This patient supposedly wore their prototype for 2 years, and within a week, they broke the zirconia. To me, it looks like there may be some milling problems. He's going to go to a bar. I was told many times if I don't have passive records, I like to use a bar. Bars are not remedies for inaccurate records. Remember that, or improper manufacturing processes. Maybe you can't get zirconia not to warp, so you're going to use a bar. That's fine. But it's not a band-aid to a bad all on X record or something like that. And for those who do these regularly, we like to polish the tissue side. Um, it helps keep the tissue nice and healthy and resist bacteria. So polish that up. Is some people think it's a pain. Takes a few minutes to get a nice polished tissue side. Here's a material study I like to talk about. This was a little bit newer than some of the other ones where you see zirconia have a high survival rate, almost 94% against the bar wrapped acrylic. And there's no different for periodontitis or implant failure. A lot of people say zirconia is hard on the implants. In the study, it says the opposite. And here's another one that supports use of zirconia for all and X restorations. Implant survival rate was 99% out of 98 patients. So keep in mind, this has been used for a long time. It does work. So you shouldn't be afraid of using it. Now, manufacturing it. All in X restorations are extremely challenging to mill. They always have been, even with the tie base. Now, you had a little bit of leniency with the tie base. Maybe your screw hole didn't mill all the way, so you could take it into green state and punch it the rest of the way out. Or maybe your tie base didn't see it all the way, so you could just ream it out. You don't have any of those leniencies with these modern screws. These screws require the seat of the screw in the restoration to be perfect. Okay. And the channels, because if the screw doesn't fit down the channel, it's likely it's not going to fit at the seat of the screw at the zirconia. And here are two more modern ones that we use in our lab. And I like to go through using these and manufacturing these a little bit more. Again, a tapered head and a flat head. But be prepared that these screws can come into your lab at any time, and be prepared to manufacture them. And that's why we partner with solutions to help us overcome the challenges of these. So it's challenging to mill. I read a lot of comments and saying, who is responsible for ensuring the success of the prosthetic manufacturer? The seller of the screw, the manufacturer of the screw, or yourself in your lab? And I say it's yourself. I'm going to put the onus on me to make sure I put this out. If you can't, find a different solution. But these are solutions to get these to work correctly. It is impossible for the screw manufacturer to know all the capabilities that every lab has in this country. It's impossible. Maybe you have a 5-axis, but you don't have a flat burr. Maybe you have, I don't know, maybe your mill's just not calibrated. And it can go on and on and on and on and on. It's impossible to know. That's why those numbers, those angulated screw channels, maybe you can't get 30 degrees because you don't have a T cutter. That's okay. It's okay to use that screw, and it's okay. It's on you to kind of figure out which screw works for what system you have. Even the best mills may have challenges with these. Um, I think it's on us to now know, and that's where I become passionate about making sure we are manufacturing the restorations properly. You can do everything right from the very get-go, and you deliver that, and your screw's not properly milled. That restorations has a good probability of failing. This is why a couple years back I had gone to hyperDENT for these types of restorations. We were struggling, and I'm not even kidding you that I could be calculating a job for 10 hours and coming back, and it would take 30 minutes calculating. You're simulating, you're calculating, simulating back and forth. And this is even maybe when we had some longer bursts, because frankly, the Sierra 13 millimeter, 1 millimeter burr is not gonna cut it. You need a longer burr. So we had to find longer 1 millimeter burrs. Um, and then the flat tool, and it just, I had enough. It was like holiday season. I was pulling my hair out. Screws aren't fitting down the channels. As we demanded more from these restorations, the solutions had to catch up. And in hyperDENT they did. We have an improved end product, improved my life balance. We calculate these things and we send them along their way. And they come out, and 99.9% of the time, we have no problems. I'm teaching this to another member of our team here, and you know, and I got a video at the end. You can do this with this. It's a turnkey solution. They have gone through and figured out the problems we had with milling these and developed solutions for them inside of hyperDENT, and they're all available once you get started with it. We use the Roland. I don't have a 53D. We have two 53DCs and three 53DCIs. They work very well, and all the tooling is available for them from hyperDENT as well. And this 53DC, I actually ran on X, I believe it was 7 or 8 of them for 24 hours straight. It never stopped. I pulled a couple out, I reloaded a couple more, and it just kept going. And we don't have any problems with that 53DC. So a flat screw, just a simple flat screw straight channel like the desk screw, needs a flat end tool. Yes, if it's big enough, a round burr could mill across a flat surface. But inside the channel, it does need. And this came up recently. I was helping another lab, and I just happened to look at their V panel, and I saw they don't have a flat end tool. And I said, there is no way you are milling these properly. You cannot mill that flat surface. And here's an example. I use this because it gives you a nice visual. The red is not going to mill. That screw is not going to seat fully. Okay. So then the bull nose. This is the hyperDENT. And when I started with hyperDENT, I thought, I don't need a bull nose. I have a flat tool. And this tool has become one of the more favorite tools. It cuts flat and round surfaces. It is very long, 21 millimeters. So we can get down to the deep ends of those larger restorations finally. Angled screw flat. You cannot mill the flat surface with a flat tool at an angle. When it comes in there, it's going to leave some residual material. It's just impossible to do. And here's an example. This photo was bragging online about milling this restoration properly angled, desk long screw. And as we look closer, it's just not seated. It's not down. So this was a failure. It puts stress upon the edges, and this is where the tapered screw milling inaccuracies, the flat screw, it can come from both screws. So you need to be cognizant of this and make sure we're milling these properly. And this is where in Chicago I started to mill responsibly. Um, T cutters. T cutters I had been looking for years, years and years ago. Everybody told me you need a T cutter, except there was no T cutter really out there for zirconia. The T cutter actually comes up through the bottom side of the multi-unit and mills the edges. So it does a very good job at milling those flat angled screw channels. It also goes in there for the angled screw channels. So some of these, like the Vortex, we were restricted to like 15 degrees angled screw channel until the T cutter. Now we can use 25 degrees because we can accurately mill the screw seat. Here is an example of the flat tool I did for this to show you. This was that simulation I showed a couple slides ago. This is the 1 millimeter ball only, the flat end tool, and the bullnose T cutter. And you can see, other than when I cut them in half, I chipped some of it. Um, that the flat end tool and the bullnose T cutter get a solid seat on the zirconia, but the 1 millimeter ball does. And if we zoom in, you can see it just is not seated all the way. There's a little bit of zirconia held that up. Um, Even more so with an angle. And I think I only went 20 degrees on this. And I sent both the flat end tool and the ball, 1 millimeter ball down that channel. And you can see how much it's held up. It's kind of cool to actually see the, I guess, trough or the milling of the T cutter coming up through the bottom on the picture on the right. And you can tell definitely you have a solid, secure seat. What do you think that screw on the left is going to do to your zirconia? It's only held down by that tiny edge. Is it going to loosen? Is it going to fracture? It could do both, right? So we need to make sure we get these milled properly. And with the T cutter, it is my belief it's the only way you're going to mill an angled flat screw at 20, 25 degrees. The hyperdent alias is a neat function when you bring these all-in-X restorations into hyperdent. It reads your CAD file, um, and you have to have a few files in there along with it. Like exocad has the construction info, 3Shape has a few files that you set up to come along with your STL, and it reads the CAD information and it can place what then is the this is the desk screw, the multi-unit RP. Place the geo then. It is the geometry, known geometry of that screw seat and multi-unit millable strategy into your all-in-X restoration. This is the automation that makes this so great. There is a large library of options. You can switch between them. So say, I don't know, let's just say your designer milled the wrong screw or designed the wrong screw, and it comes in and it's supposed to be the desk screw. You can switch that over right inside here, just changing the screw library. Um, so it's very useful. We sometimes do it with prototypes. Doctor says go to final with a prototype. Maybe we just had like the 19006 with the prototype for whatever reason. All our prototypes are direct to multi-unit, and then we'll switch them at the end. So you don't even have to go to CAD, back to CAD if you don't need to. Here is a little video of setting this up. It is a little sped up, but this is all it takes today. And I love this. I mean, I couldn't do without it. Other softwares, you can add tools and such, but this is turnkey. All the tools are built into there. Um, so you just double check to make sure your geo was picked up from the CAD. Some of the new libraries from 3Shape and exocad aren't always being picked up anymore. Um, I should go through and I delete these emergence profiles because they are right on the margin. So I don't think they're needed. So I do, if it picks them up from the CAD, take them off. There's our fifth roll in 53. Here's our cube one. I believe that's a 25 millimeters, so that would be our white that we're going to stain. And the nice thing about the even the pre-shaded Amon Gerbach and Dental Direct is that they do have some effect liquids if you like to put a little blue on the edge or something like that. Just to mention that, I forgot about that. It's very quick. The calculations come in usually around under 10 minutes. Put our connectors on. Again, I only put 2 on the buccal surface. I will put 4 if I have a pterygoid case and a longer extension. There's our support structure. We're going to go change to 3 millimeters for the lingual supports. And then the last bit of it is, and I like this feature is, oh, I could go in there and changing, you can change the strength, I guess thickness of the material around the multi-unit, but you don't need to. These are made to work. Here's what I like: the user-defined areas. They call them UDAs. This is kind of like, so if you turn your undercuts on, I don't mill everything at 5-axis. I used to be a huge sticker. I got to mill everything at 5-axis and just trust that it's gonna mill everything out. Well, I don't need the lingual milled out in 5-axis. And I want to make sure I get some of the areas that I need milled. Um, like someone milled one for me the other day and completely missed all the facials. If we would have just set some user defines in there, um, in hyperDENT, it would have been fine. So you pick usually about 3. Um, I think my mouse was glitching out on me. Posterior, anterior, you can pick them from the buccal side. You can put them from the gingival side. But even with the little struggles, which I think there was, I was working on this remotely, and that's what caused this problem. Sometimes from the anterior, like the lower anterior bridges, come from this. I don't use a lot of C clamp or open face anymore. This seemed to do a pretty good job. I'm still gonna do a little bit of green safe finishing. The results are far better than they used to be. Um, they're very clean, very little. You're just putting a little bit more finer detail in there with this approach. What's nice about the user defines is it does open up the um, perimeter to make sure you're not going to have a collision along the wall. So you just check it out. You hit the calculate button, and I'm telling you, when this thing calculates, it's done. I don't run simulations. It is done. It is turnkey. It is a um, proven CAM system, and it works very, very well. And at the end, it just generates your report. And in 10 minutes, it calculated that. So the calculation times are quite quick. I can usually run two at the same time while that one's calculating. I'm setting up the next one. So I wanted to say thank you from Zon. And here I felt like I was building a side of a NASCAR here with all these different products on here. But really, the desk screw is a winner, the Roland's a winner, hyperDENT and the Zirconia is available to you from Zon are all solutions for you to work on these cases and make sure that you're successful with them.
Thank you, Dan. Appreciate the overview. Since we did have some technical difficulties, we are unable to see the questions if we had any come across. So as a follow-up to this, we will email everyone, as always, a recording, a link to the recording here, but also give them an opportunity to submit any questions that we can pass along to you. And of course, we know that you'll get back to our customers and the attendees with an answer. And we really do appreciate you your knowledge and thank everyone for joining us.
Yep. Thank you very much.
All right, bye everyone. Have a good day.
See ya.